What we're going to do now is we're going to take a look at the case study, the big fraction case study that uses singles and some of the methods in singles. And I've broken this up into several different parts so we can look at different examples doing different kinds of things with the RxJava Single class. And you can find out more about Single by going to this link and reading the documentation. And here's the case study we're going to look at. This is called Ex1 for example one. Obviously not the world's most descriptive name, but you'll see what it does here in just a second. So Ex1 demonstrates how to apply RxJava features synchronously to perform basic single operations. Now, as you'll see, for the most part, we use RxJava for asynchronous computations, but you can also use it in an entirely synchronous way if you so choose. And you can find this example in my single/ex1 folder. So the first method, and this is the little stream we're going to look at. This is the pipeline. So we're going to say single.fromCallable, give it something that'll reduce a fraction. Then we're going to map that to convert it to a mixed string. If all goes well, we're going to print the results. And then we have this odd thing called ignoreElement at the end. We'll talk more about that. But that kind of looks a lot like a Java stream. Actually, it looks a lot like a completable future in many ways. But this is a synchronous example, not an asynchronous example. We'll talk about the asynchronous stuff next. So the first method we're going to look at is the fromCallable method. And that's a factory method that often originates in a stream where we're going to have the ability to create and return a single of type T that uses the supplier parameter to produce the value. And so in a sense, this kind of joins together the world of asynchronous reactive programming with the world of more traditional synchronous programming. So Callable is just this class that's been around since Java 5 in 2004, about 16 years ago. And what it does is it basically has a method called call that takes no parameters and returns a result. So we can use it as a factory to start things rolling. This fromCallable factory method is used, as I said, to adapt non-reactive input sources into the reactive model. And you can see the marble diagram here, which basically says that if you have a callable and the callable succeeds, then fromCallable will return a value, which you can see is the little red marble at the bottom. But if for some reason callable fails, then an exception is thrown and you won't get a result back from that. There's also a fromCallable method in Project Reactor that's defined in the mono class, which is kind of the closest thing to a single in Project Reactor, and it works basically the same way. The marble diagram looks ever so much different syntactically, but it's basically the same idea. So the callable will generate a result, and that gets returned from Callable. The next thing we're going to talk about is the map method. And map is used to transform the item emitted by this single. And this is going to look very, very familiar. So you can see map here is going to return a single, and it applies a mapper function, and it synchronously applies that. So it'll call that method in the caller thread. Now, where the caller thread comes from, of course, will be something that we'll talk about later when we talk about asynchronous processing using subscribe on or the observe on methods. But basically, this is a mapper. It takes something as input and it returns a result as the output, which could transform it, could even change its type. So map can transform the type of elements just like we saw with Java Streams map. So it's very similar, at least at a high level, to Java Streams map. Project Reactor also has a map method in its mono class that works essentially the same way. And you can see from the diagram here that you get a value, a marble coming in to map, and you can see that map's behavior transforms the input to the output. And so visually, we're going from a circle to a square or whatever. And the same thing is true here. It's in this case, this is the documentation for RxJava. We go from a circle to a diamond, right? But that's not important. What's important is the fact that it's changing the type, or could change the type. It doesn't have to change the type. It could change the value. So that's the way that Project Reactor stuff works. And you can think of this as being very similar to the then apply method defined on Java's completable future, where you take something in and it has the ability to transform it because it's basically taking a function and it's mapping it. So pretty much the same idea. Another method that's important here, or useful here, is doOnSuccess. And what this does is a little different from the other method that we looked at, the map method, because what it does is it adds a behavior or registers a behavior that's triggered when the single completes successfully, hence the name doOnSuccess. So what's passed in here is a behavior that's passed in as a consumer. And this consumer is basically invoked essentially as a callback if the thing before this, if the previous stage, to kind of use a completable future terminology, when the previous stage completes successfully, then this onSuccess callback, this consumer, is invoked automatically. The actual value that's emitted by doOnSuccess is not modified. The callback is invoked, but as you can see, we go from green circle to green circle. That part doesn't change, but there's a callback that's invoked instead. And there's also a doOnSuccess method that's part of Project Reactor that works the same way. You can think of the doOnSuccess method as being very similar to Java completable futures then except method, where if you recall, then except registers an action that has a side effect, but it doesn't actually change the output. In fact, there really isn't any output with the then except, but it's basically the same idea. You're getting something back and you're having a callback invoked on success, which is just the way that doOnSuccess works. And then the fourth method that we're looking at here is ignoreElement. And this is a completely wacky method at first. And you don't often need it, but we need it because we want to be able to integrate with our async tester framework. And what ignoreElement does is it returns something called a completable, which is yet another variant. It's another class, kind of like a maybe or a single and so on. It returns something called a completable that ignores the success value of this single and simply calls the onComplete method. That's all it does. Completable is very narrow-minded. And so what ignoreElement is basically what's called a data suppressing operator that it just simply ignores its payload because it assumes that whatever the payload was has been handled in some other way, such as a callback through doOnSuccess or registered with doOnSuccess. And therefore, its only real purpose is to indicate when an asynchronous operation has completed. It doesn't tell you what the result was. It just says it's done. And it works in conjunction with this thing called a completable. So the completable is this class that, as you can see here, represents a deferred computation without any value, but only an indication for completion or exception. And we need this. We need ignoreElement and the semantics that it provides to make our async tester framework behave properly. And I'm not going to hold you responsible for knowing what that means until we cover async tester in more detail, but just keep that in the back of your head. You'll see that ignoreElement is used over and over again as the last thing in our little chain of processing steps. And that's because we need to be able to integrate this with the async tester framework so that all these asynchronous computations can run in the background. The main program can wait reactively for them all to finish. And then when they finish, then and only then will that main single trigger allowing the program to finish after everything else is done. In many ways, this is a bit like the stream of futures collector that we talked about. It's not quite the same, but it's kind of along the same lines. Project Reactor has a method that works very similarly called then. And if we have time, we'll cover then. So then is kind of like ignoreElement. In fact, if you take a look at the diagram, you can see ignoreElement's marble diagram looks very much like then's marble diagram. So the semantics are the same, but for some strange reason, they gave a different name for it. I don't know why. Okay, so that is the end of the walkthrough at a high level. What'll come next will be actually looking at the source code and analyzing that in more detail. Sadly, we do not have time to do that at the moment, so that'll have to wait until Monday. But you can start by taking a look at that code and running it, and it should work. If it doesn't work, let me know. And you may have to fiddle around with the project settings just to make sure you have everything set up, but it should probably work. And so you can start taking a look at single and observable. They have a bunch of examples. We will walk through them all starting on Monday in great detail. But I would highly recommend you start looking at it before then, because that'll give you some hints as to how to implement your assignment number 4. Okay, so to wrap up here, there's a couple more questions. By single value, do you mean return a single value? That's correct. So unlike observable, which can have a stream of values, a single only returns a single value. Very much as you saw the way that a completable future only returns a single value. Now, by the way, that single value could be a collection, which would contain multiple elements, but what it's trying to differentiate from is returning a stream of something as opposed to a single something. How does Python return multiple values, though? I'm not familiar enough with Python to know, but I don't know whether Python has the concept of streams built into it. Again, this is not the same thing as returning a collection. Obviously, Python can return collections, just like Java can or C++. This is about having a stream of something coming back versus a single element of something coming back. So again, when you see single, think completable future, where there's a single result coming back, which will then be available when the completable future has triggered. All right, Python supports multiple return values. Great. Okay, so please keep in mind the quiz is opening here in 2 minutes or so. Please take a look. If you have any problems or any questions whatsoever, let me know. I'll be happy to help you out. Thanks, and I will look forward to talking to you soon.